One end of a U-tube containing mercury is connected to a suction pump and the other end to the atmosphere. A small pressure difference is maintained between the two columns so that when the suction pump is removed, the column of mercury in the U-tube executes simple harmonic motion. We are given a U-tube. This is the U-tube filled with the mercury liquid. This is the suppose liquid is mercury, and initially I connected the one end to a suction pump and other end is free to the atmosphere. So on applying this suction pump, there will be a potential difference between the two ends of the U-tube, and just because of applying this suction pump, the liquid will rise to some height h. Okay, this height is h, and this side of the liquid will lower down by height h. So the difference in heights on the two sides of the column will be the 2h. This condition is in the equilibrium. Means when I am having one suction pump at one end and other end is free to the atmosphere, due to the pressure difference, this side of the liquid will rise to some height h and this side will lower down by the same height h, and the difference in the heights on the two sides of the column will be the 2h. Now we are asked that when the suction is removed, suction is removed, the motion of the liquid in this U-tube will be the SHM. We have to prove this thing, that the motion of the liquid in the U-tube will be the SHM motion. As we know, when we will remove the suction, there will not be any potential, there will not be any pressure difference between the two ends or two ends of the U-tube, and the extra liquid which has risen to this height will try to regain its original position. So just to prove the motion is SHM, we just need to prove that the acceleration is equal to minus of some constant times displacement vector. Or if we are putting vectors here, we need not to put here the negative sign. Or we can write acceleration is equal to minus k times the displacement. We just need to prove this thing in order to prove that the motion is SHM. Suppose when the suction is removed, then this liquid will try to regain its position, and at any instant of time, if I consider this reference level, at any instant of time, its height from this reference level is x. Okay, and its height from this reference level will also be x. Okay, we can understand this by again redrawing the U-tube. Suppose this was the reference level in the absence of suction. This with the height of liquid. This is also x, and this is also x. If I try to write the equation of motion of this liquid filled inside the U-tube, I can write mass of the liquid into d square x by dt square is equal to minus weight of liquid trying to regain its position. So we just need to consider this extra weight, this 2x liquid filled inside in this 2x length. This weight of the liquid will try to regain its original position, and further we can write as minus volume of liquid in the 2x length into density of liquid into acceleration due to gravity. This negative sign is because the restoring force, that is mg, this mg is in opposite direction to this displacement. That's why we are having one negative sign. Further, I can write it as volume is area of cross section. I can rub this 2x because I had written this 2x in order to show that we are taking only that volume of liquid that is in length 2x. Okay, that's why I'm rubbing here in order to remove the confusion. So I can write volume is area of cross section of the tube into length of the tube, which is 2x. I had written 2x just for the reference, but now I have to put the value 2x. That's why I removed this 2x just to avoid the confusion. So I can write further it as rho into g. Further, on simplifying this, I get m d square x by dt square is equal to minus a 2a rho g into x, and this implies d square x by dt square is equal to minus 2a rho g by total mass of liquid into x, and we can easily see that this is the equation of an object or anything which performs a simple harmonic motion, because for the simple harmonic motion we have standard equation as d square x by dt square is equal to minus some constant times the displacement. If we compare the derived equation with the standard equation of SHM, we can know the above liquid in the U-tube will perform an SHM. To calculate the time period of SHM, we can further solve d square x by dt square plus 2 times area of cross section of tube into density of mercury into acceleration due to gravity. This mass of the liquid can be written as volume, total volume. This is total volume into density of liquid, and total volume can be written as area of cross section of the U-tube into the total length of the liquid filled into density. So I can write it as A L rho x is equal to 0. This A gets cancelled. So I will get it as d square x by dt square plus 2, also this row gets cancelled, 2g by L x is equal to 0. Okay, so I know with the standard equation of SHM, this quantity is omega square. This is 2g by L. Further, I can write as omega is equal to 2g by L raised to power half, and I know I can write omega as 2 pi by t. This implies omega is 2 pi by t is equal to L by, sorry, I have done a mistake. This is 2g by L raised to power half. This implies time period of oscillation is equal to 2 pi under root L by 2g, which is the required answer.